methods. In the last module, we discussed about the basics of the plane table surveying. In this particular module, we will be discussing about the methods for plane table surveying. So, the content is methods of the plane table surveying such as radiation, intersection, traversing and resectioning. Further, the resectioning method can also be classified under two categories, basically compass and back ray method. In addition to two particular cases, that is 2-point problem and 3-point problem. We'll have discussion of solution of 2-point problem and 3-point problem. As you learn the content, you'll be able to demonstrate various methods of the plane table surveying, as well as you'll be able to state special methods of resectioning as a surveying technique. You will also be able to explain the Lehman's rule to provide solution in form of 3-point problem. So in the last lecture, you got introduced with this particular concept of plane tabling, in which we are using the plane table which is set on the tripod at convenient height. We make use of various accessories like drug compass, eyelided, telescopic eyelided, U-fork and even some minor equipment to enhance the plotting of all the features that we see around the station that is occupied by that particular plane table. So it is a conventional method of land surveying. Though it is less accurate, it provides quite a flexibility as far as the catching and plotting of the details on site is concerned. The surveyor can make use of various methods as radiation, intersection, traversing and some particular cases related with resectioning. The first method is radiation method. Here, this particular rectangle is representing position of the plane table. As you know, the stations which are present on the ground are presented with the capital letters, whereas the respective positions are shown as small respective scripts. So here this capital A is presented with small a in order to represent that position of the station. So in radiation technique, the way you see, the plane table is occupying mostly a single station, single position, so that all the features that we wish to plot, such as A, B, C, D, E, can be seen from that particular station. So the surveyor chooses some convenient station, capital O. He picks up that particular position of capital O on the paper as small o. He represents the magnetic north in the upper right corner so that the table is properly oriented. He chooses proper scale factor in order to present all that particular features. So now through O, by making use of either plane eyelided or telescopic eyelided, station A can be sighted. distance OA can be measured either directly or it can be measured by making use of certain indirect methods such as studier methods. As such, the distance capital OA will be reduced to small oa with certain scale. The same process will be followed for station B, station Z and whatever the feature that we wish to plot from that particular station. As such, here for this particular case, the way you see that particular pentagon A, B, C, D, E can be reduced to the pentagon the way we have presented on this particular paper. So the method is very easy. The only thing is we must be in a position to sight that particular station, as well as we must be able to measure the distance up to the station from the instrument station. In addition, the way we discussed previously, if one is interested in making use of certain minor equipment, we can facilitate some other operations with this particular method. Second method is intersection method. Here the way you see, this is first instrument station. So the instrument station plotted is O1 and now we wish to plot the features, say for example corners of the building such as capital A and capital B. So from O1, now the station A will be sighted, ray will be produced towards that particular A and it will be named as say O1A. Similarly, here the station B will be sighted and ray will be produced as O1B. We need not measure the distance O1B, O1A and O1B in field. Now, say next station we wish to move on is instrument station O2. So here now we'll sight station O2. We will measure the distance O1, O2 and we will plot this particular station O2. Needless to say, plotting of O2 is following principle of radiation method. So, now we can have this particular table shifted to O2 by making use of plotted magnetic meridian or by making use of back sighting. We can level the table, we can center the table, we can orient the table at station O2. Hence, the position that is occupied at station O2 will be very similar to the position that was occupied at station O1. Now, from this particular station O2, we will again look towards station A and we will produce the ray intersecting earlier ray plotted from station O1 at small a representing station capital A. Similarly, from O2, we will sight this particular station B. We will produce the insector and accordingly here the intersection of this particular produced ray towards the earlier plotted ray with respect to capital P will be giving us the exact location of P. So here having the intersection of the rays produced from this particular respective instrument stations will help us to plot this particular line AB. Say by some or other method, if we have some running measurements of this particular structure, that is if we have measured this particular size of this particular structure, we will be able to plot that particular structure entirely. We can experience one beauty here, that we are not touching capital A or capital P. Hence, Even if capital A or capital B is lying at some other plane other than the, say, horizontal plane, will be able to plot their locations. Even in addition, we'll be able to determine their particular, say, length of the sides as well as their areas by making use of certain indirect methods as such. See, here just we are considering two stations simply, capital A or capital B. But we could be dealing with lot many such corners or a lot many such features in order to plot. That's why there could be requirement to produce a lot many such rays. So unnecessarily at station position the rays could be smudged and may, say, hamper the quality of that particular drawing as such. Instead of drawing all this kind of radials starting from this particular instrument station, even if you produce the ray outward towards that particular respective stations, and if you name that particular stations by some, say, your own convention, here the way it is shown as 1, 2, 3, 4, 5. So similarly here, as you occupy the next station, ray should be named as same. That is, ray 1 should be intersecting with the ray 1 produced from subsequent instrument station. So here this won't create the confusion as far as, say, plotting of the features is concerned. So this method is most suitable for certain, say, broken boundaries as well as even if that particular stations are not, say, accessible directly, we will be able to have that plotted by using intersection method. Even it is quite probable that if certain distances are to be determined indirectly, one can follow this particular intersection method. Needless to say, clubbing of the radiation with this particular intersection method will enhance the quality of the work. But in fact, though we mention these particular methods as, say, radiation, intersection, and now the traversing, all these particular three methods can be suitably clubbed together in order to facilitate trend tabling operations. So the way you see here, we wish to plot this particular feature under consideration. So we have established some horizontal control by choosing some closed traverse A, B, C, D, E, A. We can have even the open traverse if required. So the way you see here, from station A, the rays are produced towards the various corners of the features as well as the stations under consideration. So here from station A, now we wish to move along A, B, C, D, etc. Hence the ray is produced towards B. As well, here back ray is provided towards station E also. So now from A, the rays that are produced, as we move the station to B, the intersectors that will be produced from that particular station will help us to plotting the stations, and this particular operation of carrying out producing the rays and having the subsequent intersectors will help to plot that particular feature. So when we reach at the end of the station, all the features that are under consideration will be available on that particular drawing. One more thing is, see, the way we considered here, say we have produced certain ray AE from station A. At each of such stations, we are having the orientation correctly done. So, say, as we come back to station say D, and accordingly as we cite station E, say by radiation method here, it will help us to plot the station E at station D. Here, the plotting of the station E from D should be same, should be giving the same position of the E which was obtained from station A. So here we can follow certain lot many intermediate checks. The way you see here, from station A we have produced certain check line. As we go to station B, this check line facilitated the further checks on our work. So here, this is the way we carry out our traversing. And now here, as you see, we are clubbing here radiation, intersection as well as traversing. So these three methods are commonly adopted for most of the features to be surveyed as land surveying technique. Now, resectioning is a particular case. Say for example, the way you see here, as a part of surveying, we may be using certain, say, conspicuous stations such as, say, tops of the temples or the spires of the churches or the tops of hillocks. So these particular stations will help us to enhance the quality of our, say, plan that we prepare as far as plotting of the features is concerned. But all these particular stations won't help us to establish the plane table on their top. Say for example, on the top of the temple, we cannot set our, say, plane table. Or on the spire of the church, we cannot set our plane table. On the top of the hill, we can set the plane table, but we may not be able to see all the features which are, say, low lying. Hence, now the surveyor may feel that instead of going for this particular, say, top of the temple, church, spires, which were, say, used as, say, or traversing stations, he may choose some additional stations, position of which was not plotted on the paper as such. So, from that particular station, if surveyor feels that lot many features can be easily plotted, he has his own flexibility. So the only thing is now he must be able to occupy that position of the table which was not located on that particular drawing sheet. So here that particular location of the plane table is unknown and it should be determined by citing it to known features which are available on that particular drawing. So the basic principle of this particular resectioning is opposite to that of method of intersection. This will be more clear as we move further. So the way you see here, we are making use of plotted position A, plotted position B, existing position capital A, existing position capital B, plotted north direction and these such things in order to determine the position of small o which is existing as capital O on the ground. We can follow numerous methods. The way you see here, we can make use of compass method, we can make use of Bakare method, we can make use of 3-point problem, we can make use of 2-point problem. But you should note one thing, which is nothing but the characteristic feature of the resectioning. Here, resectioning is more related to plot the station occupied the plane table rather than obtaining the other stations or plotting the other features. So, Having this bone in the mind, now we can continue our discussion with some other aspects. So the first method is compass method of resectioning. This method is useful for small and rough work in the absence of local attraction. That is, we are making use of drop compass. So here, if the drop compass is influenced because of certain magnetic influence that is prevailing on the site, the magnetic meridian which is already plotted on the paper won't be received and we cannot refer it correctly. That's why we wish to have this particular method used in the absence of local attraction. The method as such is very simple. Now, again, there is station A, there is station B existing on the ground. Their plotted positions are small a, small b respectively. We wish to determine the location of this particular small. This magnetic north direction is already plotted on some other station which was previously occupied. Now, we'll keep this particular compass along this particular magnetic meridian when we roughly center and level this particular plane table on the station we wish to plot. Now, this particular needle won't be giving the magnetic meridian because the orientation is not correct. Now, what we can do is we can release the clamp of that particular plane table and we can rotate this particular plane table conveniently so that the magnetic needle will be giving the magnetic north direction, which will be parallel to the magnetic meridian which is plotted from earlier station. So, as this particular thing is done, we can clamp the equipment. Now, through this small a, sight capital A and produce the ray backward towards the station to plot. Similarly, look capital B through small b and draw the resector back. The intersection of these two rays will give us the location of the station we wish to determine on the paper. As we have produced this particular rays backward, this particular ray is called as resector and the method is resectioning. We can also make use of back ray technique for the resectioning. It is useful only if the station that we wish to plot as small o, representing ground station O, was already selected and ray was produced from one of the earlier station, but its exact location was not marked on the ground. In order to have the explanation, now we will assume that certain ray was produced from station A here. So the way you see here, the instrument station is 1. So the procedure is set up the instrument at A with reference to this particular plotted A and carry out leveling as well as centering with respect to A. Now, align the LED along line AB. So here this location of the B is available on the paper. So we'll make use of this particular, say, line AB plotted on the paper representing capital AB. So here as we cite capital B, we'll be able to orient the table by citing capital B. Prior to that, even we can make use of, say, a drop compass in order to have the rough orientation. Now, here we will mark this particular station O after citing it and producing it in the form of ray AO dash. So now here we will mark this O dash representing station to plot roughly. Now we'll shift the plane table to this particular station O. We'll carry out all that particular temporary adjustment and we'll set the equipment exactly over capital O by assuming O dash to be the correct location representing that station. Now, from this particular O dash, we'll take backside to A and we will clamp the table. As such, here the orientation is done through backsighting as O dash A. Now, we'll look to B through this particular O dash and we will produce the back ray as BO double dash. Here, this ray won't pass through that particular say O dash, but it will be intersecting that ray produced towards that particular O dash, giving the location small o the way it is shown here, which is correct location of the station we wish to plot. Now, having determined this particular location, if there is some existing station C which is plotted from earlier position, we can produce the say ray towards that particular station C, and by using one of the techniques of the plane technique, we can determine the location and we can check whether we are getting the same position or reasonably acceptable position of the plotted position. We can go for 3-point problem in order to have resectioning done. This is a special case of the resectioning to obtain the position of the station occupied by the table with the help of given 3 stations visible from the instrument position and by making use of their respective plotted position. So the objective is to orient the table correctly so as to obtain the position of the station on the paper occupied by that particular table. We can have this particular say 3-point problem stated as to plot the station occupied by the plane table on the paper with a table correctly oriented with respect to 3 points which are already plotted. Principle wise, you can see here that this particular rectangle is representing that particular plane table position. This P is representing the ground station. The intersectors moving through X, Y and Z through the respective positions small x, small y, small z are giving the exact location of P only because the orientation of that particular table is correct the way it was at all these particular stations X, Y, Z while plotting their particular respective positions. There are number of methods as far as solution of this particular 3-point problem. One can make use of trial and error method. It is also called as Lehman's method. There is another method which is called as mechanical method. It is also called as tracing cloth method, graphical method, analytical method, even there is certain geometric construction method. This Lehman method or trial and error method is giving us accurate solution as well as practically it is mostly applied. Another thing is, though there are number of such solutions, today we have got number of better options in order to facilitate land surveying technique. Though plane table is very convenient approach as far as on-site plotting is concerned, one need not complicate that particular plotting process by entering into this particular 3-point problem or 2-point problem or resectioning. But one must understand this as a technique, hence just To get the feel of that particular method, we'll discuss about just one of the methods, which is nothing but Lehman's method. So in 3-point problem, if the orientation of the plane table is not proper, the intersection of the three resectors through the 3 points will not meet at a point, but will form a triangle known as triangle of error. So the way we discussed on earlier slide, we considered about 3 stations, capital X, capital Y, capital Z. Having the orientation correct, the rays drawn towards it and their intersection is giving us exact location. But say here, if the orientation is not correct, now these particular 3 rays will be causing this particular triangle to form, which is called as triangle of error. The size of this particular triangle of error depends on amount of angular error that is involved in this particular orientation. So there are certain guidelines that we can adopt for this particular Lehman solution. It involves minimizing this particular triangle of error to a single point iteratively. The iterative operation consists of drawing of these particular resectors from node points through their plotted position and the adjustment of orientation of the plane table. The estimation of the location of the plane table depends on its position relative to the well-defined points considered for this purpose. Depending on their relative positions, there could be 3 cases. The first one is the position of the plane table could be inside the great triangle. The position of the plane table could be outside the great triangle. The position of the plane table could be lying on the circumference of this particular great circle. Let's try to understand what is meaning of this particular great triangle and great circle on subsequent slide. So we are defining this particular triangle ABC on the field as a great triangle, and the circle passing through this particular station ABC as great circle. So having this particular terminology of great triangle and great circle, Lehman's basic rules and their supplementary rules are used to estimate the location of the plane table which is not plotted on the paper. So if the position of the plane table is inside the great triangle, so the way you see here that diamond point representing ground station T is lying within that particular great triangle, then its plotted position should be chosen inside the triangle of error that is formed the way we discussed on previous slide. Similarly, here the way you see this diamond point is representing capital T, which is outside this particular great triangle. Hence, its position should be chosen outside the triangle of error, the way it is shown to be certain, say, purple dot marked with small t. In addition to these particular broad guidelines, one is expected to follow these 2 rules meticulously. So the first rule tells us that the point P is always on the same side of all 3 resectors. See here, Once again, capital A, capital B, capital C are the ground stations. Their locations, their respective locations are small a, small b, small c. Now, we wish to plot the position of P representing capital P, that is existing on the ground, by making use of ground stations and their respective locations A, B, C. So, through small a, by citing capital A as we produce the resector, similarly, through small b, by citing capital B as we produce the resector, as we produce this particular resector, similarly through this particular C and capital C, there is formation of this particular triangle of error. We wish to determine the location of this particular P. In order to do further proceedings, we'll be assuming this particular location, and we have to have this particular position according to the first rule of the Lehman, that the way you see towards a resector, it is on the left side. Similarly, it has to be on the left side of BB, left side of the CC, simultaneously according to the first rule. Second rule tells us the distance of P from that particular resection line should be proportional to length of that particular station from the respective ground station. So, in simple words, say here if this capital A is farthest station, the location adopted of this particular P on the paper should be farthest as compared to its distance from resector B, resector C, and accordingly. So, here mathematically P1 by PA should be equal to P2 by PP should be equal to P3 by PC. Tentatively, we are not performing any calculation in order to have these ratios exact. So, to arrive at the solution, we will select this particular position P dash satisfying these two rules. Now, we will keep the elided along this particular P dash A and rotate the table to site A. As we bisect A, let's have the table clocked. Having done so, now the orientation as compared to what it was is more correct. Having this particular table clocked, let's have these particular resectors BB dash and CC dash plotted. So the way you see here, earlier this was the triangle of error, but now its area is reduced. So now we'll go for the next trial, that is we'll have this particular P double dash by having consideration to these two rules, that is that P double dash should be always on the same side of all these particular three resectors that we are going to produce. Its distance from the resection line should be proportional to length of that particular line and such things. So again, as we have these particular resectors, this particular area of the triangle will go on reducing, and ultimately after say 3-4 trials it will reduce to a single station. These rules in fact are enough to arrive at the solution. But if the plane table happens to lying on the circle passing through all that particular three locations A, B, C, which is nothing but the great circle, it won't give us the required solution. In order to have the further ease to arrive at the solution, we can make use of supplementary rules. So This particular slide is giving us some typical cases elaborating these supplementary rules. So the first case, if P lies within the great circle, the point P should be lying within the great circle to create the solution as P1. If the plane table station capital P lies outside this particular great triangle, then the point to choose at P2 should also be lying outside that particular triangle of error. If the station P is on the great circle, the way we considered earlier, and giving the location or showing the position as P3, P4 here, we cannot arrive at the solution. If P is outside the great circle and if P is near to the intersection of the rays to the nearest points, we can have the location P5 as P5. If point P is outside the great circle and the two rays drawn are parallel to each other, the point sought is outside the parallel lines and on the same side of three rays, the way we have shown as P6. The way you refer the literature, you will come to know across the various provisions as stated by Lehman. We'll have these particular conditions elaborated through small cases, the way I have tried to present here. So, say first case. Here, this capital T is the ground station. It is outside this particular great circle ABC. We wish to have its location as small t. It should always lie on the same side of the ray drawn to the most distant station as the intersection P of other two rays. So the way you see, B is most distant station. Here the intersection of other two stations is giving this particular location small p. Hence, this T has to lie on the same side of the ray drawn to the most distant station, the way it is sought through the intersection of these two nearest stations. Further, the intersection of the two rays to the nearer points is midway in between the ray related with the distant station and the location that we wish to plot as small t. Case 2. Now, when this capital T falls within any of these particular three segments formed by the sides of this particular great triangle ABC, the ray towards the middle station, the ray towards this particular middle station lies between the point to plot and the intersection of these two rays. Case 3. When capital T falls on the great circle A, B, C formed by the stations of this particular great triangle ABC, three rays will always meet at a point even if the table is oriented in any manner. Hence, the solution is not possible at all. One more terminology related with this particular 3-point problem is called as strength of fix. In simple words, it is the accuracy with which the plane table station can be located after solving this particular 3-point problem. The degree of the accuracy of the solution of this particular 3-point problem is designated as strength of fix. If the accuracy is high, the fix is termed to be stronger. If the accuracy is low, the fix is termed to be poor. The accuracy of this particular fix depends on the relative positions of the plotted points and that of the location of the plane table station, the way we discussed through number of slides previously. Thus, the choice of plotted positions and location of the table should be made to get strong fix. We can attend these particular following points. Select the location of the P nearer to the orthocenter of the great circle ABC. So here this particular P, or the way I have presented it as small t on certain slides, is nothing but the ground station we wish to represent it as on the paper. Do not select it near on the circumference. When position of the plane table is outside the great circle, select the station near known middle station. If plane table is within the great triangle, middle station is much nearer to its position on the paper than other two stations. So, when you actually perform the steps, the idea is more clearer. The way we made use of three stations in order to determine the unknown location, in the similar manner, we can also make use of 2 points existing on the ground and their respective locations of the paper in order to have the orientation done correctly. Here again, one can make use of some 2-3 methods like Bessel's method, graphical solution, etc. I am not going to discuss this particular method here, but one may refer the series of steps that I have given on this particular slide. One may also refer the related matter available on some such sites or even the standard textbooks. While discussing about the basics of the plane tabling as well as while discussing about the methods of this particular plane tabling, I am trying to discuss about some tips which will enhance the quality of the plane table survey. Just to have small recap, there could be some errors involved because of this particular, say, atmospheric conditions or natural conditions. That is, there could be too much glare on the paper because of which we cannot plot the rays exactly, or we may not be able to bisect the object exactly because of their brightness, because of the moisture present or the absence of the say moisture. The paper could be too dry, hence it could be brittle as such, or it could be damp. The ground on which the equipment is set could be loose one, hence the sinking of the tripod is possible. The stations could be locally affected. Even there could be number of things because of which instrument may not be working properly. Say the top of the table could be warped, the beveled edge may not be exactly straight and it won't be parallel to the line of sight. Side vanes may not be perpendicular to the base of the alidate, or there could be certain slip of, say, plane table. The needle may be too sluggish. The drawing sheet that is fixed on the top of the table may be slipping. The tripod screws could be loose and hence it could be unstable. The level tip we are making use of may not be giving the required precision or required sensitivity. Even the surveyor may be committing a lot many mistakes while setting up the equipment, centering of the equipment, leveling of the equipment, and say orienting. As well as even the sighting could be considerably affected. There could be lot many mistakes which could be related with this particular say, measurement of the distances and their respective scaling down and plotting. So, in order to have the better results, the surveyor must attend to these particular factors and similar to that. Let me repeat once again. This method is very convenient and it helps us to have fill in the details as a supplement to any major kind of a survey, including theodolite traversing. Hence, it has its own beauty. I hope the factors that I try to discuss here are clear to you. So, thank you for your attention. In the next presentation, we'll discuss about now theodolite construction and its use for land surveying. So bye till then, I wish you very happy learning. Thank you.